Good morning. This is a little weird, so pardon me if I sort of scream through the microphone. You have a volume adjustment on the side. One of them is channel, the other one is volume. You should be able to adjust the volume so that you don't hear my breathing and other things coming through. It can get tricky, but otherwise I think we're good to go. Good morning. I hope all of you had a great time today, and it's really thanking all of you for making your time available for us to listen to us, to hear about us, hear about our customers and our journey. So the next 30 minutes, I'm going to be talking about digital transformation, and this is a story that many of you would have heard quite a number of times, right? And digital transformation, the classic story that you constantly hear is the fact that it's disruptive, it's going to change something else, it's going to be very challenging, etc. That's true. I mean, it's there, it's in front of us. We have to make the necessary changes to make sure that we succeed through this journey. The why part is generally understood. I mean, there's a lot of people talking about why digital transformation, and then there is the whole construct of what should I do, how should I do, and there's a series of sessions happening out here that talks about how you have to organizationally realign yourself, how you need to restructure your culture, how you need to think about innovation, so on and so forth. In this session, I'm going to be primarily focusing on how does a CTO or a technologist look at digital transformation. I mean, the classic challenge as a technologist that you have is that the needs from the business will not be articulated very well. I mean, digital transformation is so disruptive, they are not going to be able to come to you. The business team is not going to be able to come to you and say, I want you to go build this. The reason is they don't know. Very important. They just don't know because it's an experiment, it's ideation. So they are experimenting on their business, expecting you to experiment on your technology as well, simultaneously. And that's sort of a very interesting situation you put yourself in. Then if that is the context in which you want to do digital transformation, the question you need to really ask yourself is, how do I do that? Right? As a technologist, how do I build myself? How do I structure myself so that what are the principles do I follow so that I can go ahead and build solutions for them as their needs change? I mean, this is the classic challenge that we have, right? Your change request cycle is going to be very high velocity. So we're going to talk about some very simple principles on how to approach that. The first section of my slide deck is going to talk about the disruption and the opportunities and why it is. Very few minutes on that. Then we're going to talk about the microservices evolution and how microservices assist in this construct. Then we're going to talk about chaos architecture through which you can actually evolve and develop fairly highly available applications, and how do you structure teams in your organization as an engineering team to actually deliver against this need. So far so good? All right, very quickly. So the rest of the slides I'm going to really fly. So how does the whole world of IT look? Today, when you look at IT, your IT is essentially, I mean, if you're in the enterprise space, if you're in the small and medium business space, your IT is essentially a function of the solutions you offer to your employees. You're building a piece of technology that focuses on the employees. It's the number of employees, the number of email IDs in your company, the number of SAP users in your company, the number of expense reports that are submitted, the amount of business that you do. It's the employees who drive the scale of your IT. It is the number of factories, the number of stores you have, the number of channels you have that actually drives your scale. So classically, when you do capacity management in IT, you would look at it and say, I am going to look at how many stores are we expanding. Right? I mean, I have friends from automotive industry out here. They understand their entire scale depends on thought process that says how many dealerships are we expanding so that you actually increase the size and scale of your infrastructure. If you are doing marketing, you start looking at what kind of channels do I want to address and how much data am I pushing towards. That's traditionally how IT sizes and scales infrastructure, which is fine. But the minute you get into the new world of IT, the way you are now building digital products, the fundamental challenge shifts away. Your employees have started becoming highly mobile. The very same employees who are using desktop applications and traditional solutions have started becoming, the sales guy does not come to the office anymore to enter opportunities. They are not entering information from very fixed locations. It's not the network capacity. They want to access data 24/7 anywhere on the planet, any given time. They want to be able to do their expense reports. Your employees want continuous access to information. Your factories and your stores are starting to do just-in-time inventory. They're starting to do just-in-time transactions. You're starting to do e-commerce. That means you are going to have transactions. That means the customer is going to come to you and start shopping whenever they like. You are not going to be able to say, today my store is closed because, we're going to do something and therefore we're doing our upgrade to our retail POS system. Don't come to the store today. It doesn't work. Such a concept doesn't work, right? And if you do that many number of times, customers will stop coming to your e-commerce store. The same thing happens in your sales channels. The same thing happens as you go towards marketing and social media. Then anybody can post a tweet anytime. Anybody can post a post on Facebook anytime. That means you are continuously responding and accessing and processing that information. That means downtime or maintenance time is not something that's accepted. Now, in this new world of IT, not only are we faced with this new challenge, like IoT bringing in data, customers bringing in data, we are also faced with another challenge. We want to innovate even more faster. Now think about this. You have a deluge of data coming from all over the place towards you, and you are impacted by another technology challenge, is that the business comes to you and says, I want you to improve this in this cycle. I want you to make a change here. I want you to try another experiment here. I want you to try something else different here. How do we build this? And that's the construct that we are going to go over. Right? And these new needs are driven by the personalization that's driven by the business, the amount of customer tracking that we want to do, and the new channels through which you want to interact with customers. Those are the primary drivers that's driving that. So the key behind all of this is the nature of your business logic and the nature of your technology architecture. Traditionally, IT has been what we call a monolithic architecture, and monolithic does not mean bad, right? Not in the sense bad, but when you think about applications, what we do is we buy an entire application, we drop it in, and then we say this application is going to go ahead. And the way to understand what is a monolithic application is very straightforward. When you do release management in your technology, think about it. Does it impact other aspects of functionality? I make a small change to my sales functionality, to my shopping cart functionality, to my marketing functionality. Does it impact other aspects of my system immediately? Right? Do I deploy a very large jar file? Do I deploy a very large run to production, and that requires several hours of downtime or even several minutes of downtime that impacts other aspects of the system? Think about it that way. That's a monolith. Right? Which means your application is not partitioned and fine-grained enough in a construct that allows you to deploy freely. A lot of people develop as microservices. At least they think they're developing on microservices, but eventually what they end up deploying is like this big monolith which breaks other things in the back. Right? That is a monolith. Monolith is how we did IT for a very long time, and there's nothing wrong with that. But we need to change. That's what it is. Microservices architecture is about thinking about the same construct a little differently. The nature of the contract between these independent, disparate solutions, how do we structure ourselves and how do we do that? But then comes the next evolution of that, right? Now we're starting to think about functions, very native, cloud-native functions, and how we want to drive applications to a very new style of building, because it forces you to think your application architecture very differently. And we look at all of this and how we evolved to this space. So about 10 years ago, maybe more, even older, I don't know, right? What we had is we had these big monolithic applications. We split them up, and we call this service-oriented architecture. And we split them up, and we used to pass information back and forth using XML and SOAP, right? Any number of data integration topologies, and we used to pass this data back and forth. Remember, your network architecture in the data center only supported that velocity of data movement also. It's not just that, right? And this information that was going back and forth allowed us to independently innovate. So you had an ERP system, you had a supply chain system, you had a CRM system, and these systems could interact between one another. That's 10 years ago. That's the architecture we all tried to get to. Some organizations took a long time getting there, but we eventually got there. Then, that moment, the next 5 years, we said we can accelerate this much better, and we can transport data much faster, fast binary encodings, faster way of communicating between these systems. We moved to JSON and REST-based solutions, so that you don't have the payload of processing XML, right? And we did this processing that went back and forth. And eventually what happened is these big blocks actually started splitting into multiple smaller pieces as microservices. What are these microservices? Each one of them. So your shopping cart is a microservice, your product catalog is a microservice, your order system is a microservice, right? And we started building these discrete functional components that become, if you're building custom applications, this was a very natural way you started thinking about partitioning yourself. And which is good. And if you're still not doing it, that's the way you should be, at least minimum trying to do that. And that's the range we went to. Now, if you look at your order management system, that order management microservice, your product catalog microservice, you will tend to have quite a number of services that are actually, or quite an amount of code that actually does more or less the very same thing that your product service also does, right? And we'll get back to that as we get through the slides. So these microservices, have the ability to interact. That means you could deploy any one of those small bubbles, that circular thing out there, which should not impact any of the other services. So when you deploy, make a change to your order management system or order service, it did not impact your catalog service, hopefully, right? Because if it did, you're still a monolith, right? So you had to partition it such a way. It's a contract, right? Developer A develops order, he develops product catalog, he develops a ticketing system, a ticketing engine, the other person develops another construct around how to compute the invoice, etc. Each of these bubbles had a way of enabling you to separate that logic independently, and deploying each one of them should not have created a failure. Then when we looked into that service, like they were explained to you, you would have the same mechanisms to connect to a database, the mechanisms to ensure data consistency is there, the data availability is there. The very same order service tends to have quite a lot of logic that is something that's also found in the product catalog code, which is also found in your ticketing code, that is also found in your account management code, available in your contact management code. Each of these microservices had the same mechanics set up so that the reliability of the application, the availability of the application is actually managed. And queuing, etc., right? Now what happens is you step back and you say, okay, what is the differentiator between these microservices and what is the common code? And then if you start looking at how AWS gives you those microservices, when you look across AWS services, what you have is you have things like API Gateway, SQS, DynamoDB, Kinesis, SNS, Amazon Simple Storage Service. These are services that are like Lego blocks for you, correct? That means the only thing you really need to differentiate is, can I just write my business logic which acts as a glue? Think about it. If you have to take Lego blocks, can I build an aircraft with it? Yes. Can I build a house construct with it? Yes. Can I build a car with it? Yes. You can build different things, right? The only thing that you need is the mechanics and the glue to actually make that happen, which is in a sense what your business logic was. That's the one that distinguished between your order, your ticket, your product catalog, your order, customer order management, etc. That is what we call a Lambda function. That's what becomes functions as a service. Now, these functions is essentially the logic that controls what is it that you want to deliver and how you want to deliver. You put them together, and when you deploy them on Lambda, one of the key advantages you get is that these functions can stand themselves to be ephemeral. Now look at this example. A customer makes a request, hits an API gateway, the Lambda function invokes itself, opens itself, launches, makes the necessary service call, and then it completes and it shuts down. Right? These functions can launch sub 100 milliseconds, fire off, run, execute in a couple of 100 milliseconds, restore back, and it goes away. Now the beauty of that is, if nobody is calling that service or making that call, there is no cost to you. If a lot of people are calling, it is going to naturally explode and expand. So if you have 5 million people hitting your website, you're not launching infrastructure, right? The function is going to have enough containers on which internally it's going to fire off, creating enough copies of itself so that it can service all of your demand. At the same time, when nobody is hitting your service, there is no server running, there is no infrastructure running, all of that goes away. So that's how we get to a very, very cloud native architecture over time. Correct? Think about it. We started, what we did 10 years ago is we launched VMs, and VMs are really thinking about it. What we did in the data center, we put that on the cloud. 2005. When you say I'm launching an EC2 instance, what you're doing is using fairly a little bit older, but the mental model is that you have to think about you're launching a VM which is 2005, 2006 mental model. Then you have containers. Now you have functions. Functions allow you to think about the very nature of your processing, the very nature of scale, the very nature of availability very, very differently. That's cloud native architecture as we get to. So today, if you're trying to transform your organization, if you want to take that forward much more successfully, instead of thinking about, okay, how do I move to containers or how do I change some aspect of my code today, you might as well leapfrog yourself to the next generation from that monolith to functions and move forward from there. You can always use other architectures. At AWS, we love all kinds of architectures. We support you in all these architectures. But here is a recommendation, a thought process on how you want to take it forward. Right? So that's monoliths, microservices, and functions. So this is the focus on how to get your business logic then. The second challenge that you face is that if your business logic is that way, how do I deal with my database? Because all of these beautiful services that will scale enormously comes with another challenge. Your database being the single point of failure, single point of scalability challenge, right? You have to make all these connections, you have to drive that through, etc. The advantage with cloud is that it allows you to take this relational database that you currently operate and split them up. I mean, that's how your database would have grown over the years, but then it allows you a number of choices. In Amazon, for example, we offer database migration services, DynamoDB, which is a key value store. We have managed RDS, relational data services. That means you can scale your database linearly as your services grow, as your functions grow. They don't have to be in the same place. And you can take these services and untangle them and deploy them into remember, the microservices is an encapsulated component. It doesn't have to be in one single massive MySQL or Oracle or SQL Server. You can actually split them up, right? And based on the case, for example, if you're building a shopping catalog, probably the right way to store that is a key value store. If you're building a contact management system, it's probably directory style service. If you're building a product catalog, it's probably a hierarchical database, right? And if you're building a ticketing system, probably a relational database. You don't have to stick yourself to one single metaphor of storage to store. And if you're storing large amounts of blobs, like for example, IoT data and sensor data, the best thing is to store them in object storage and simple storage service directly, right? You can use this Kinesis Firehose and actually stream the entire data into object stores. You don't have to tie yourself to a single database format. Keep them there. Of course, there are other challenges when you start distributing the data. The way you deal with that is you basically say, now how do I take these schemas and systems that are there? But if you look at the modern analytical systems that you're building today, they actually do schema on read. They don't do schema on write. Right? If you're doing schema on read, that means your databases can be spread across several systems. You can actually move that to a data lake, and from the data lake, what you would do is you would read the data on a schema on read basis, which will allow you to look at the real value of truth, the real context of your customer, the situation that you're in today, the business current state, etc., and do intelligent processing, whether it's AI ML, whether it's descriptive analytics. You can drive that forward. So that's the first case. This is the way you would look at, that's the way you would look at business logic. That's the way you would look at databases and start looking at re-architecting applications for digital transformation, getting yourself ready to go and drive that. As changes come to you, you're just writing new functions, new capabilities, right? So change request is not something that is an enemy to you. It is a yes to you, right? You're only writing functions now. Now comes the more interesting challenge. Now that I have written all this, I've done all this, how do I ensure that my application is actually ready, available, and take it forward? And here we look at constructs around chaos architecture. Chaos architecture basically talks about 4 layers and 2 teams that needs to be in your organization, and most importantly, an attitude, right? What are these 4 layers? We'll go through them, and the 2 teams and what their responsibilities are, and the attitude that they need to have. Right? First one, infrastructure and services. Here I'm taking an example of AWS. AWS services today operate in over 18 regions, available across 54 availability zones, can service well over 100 plus countries, and there is no single point of failure. You can design architectures that actually cut across this, and let's say there's a customers who are coming in actually went a little bit faster. Customers are coming in from any of the locations. You have the ability to scale and distribute yourself substantially wide, right? If you don't have a single point of failure, what are the things that you need to structure yourself? You need to make sure that your solution is distributed, your solution is replicated, right? No single point of failure will solve the problem around distribution, will create the resiliency around single points of failure. Replication will again solve the solution around single points of failure. Both of them put together, if distribution creates another challenge, is that how do I ensure requests are managed automatically? You can automate that. If a code is in one region, how do I take the code to another region? How do I deploy it across region? How do I move data from one region to another? How do I move my rules from one region to another? You can do that by automation. CloudFormation, you have scripts for deployment of code, you have scripts for deployment of solutions that you can actually use to do that through that. Replication is a very natural capability on the cloud. This is actually hard to do in a data center. If you are building data centers today, it is very hard for you to build replication. You actually have to build substantial infrastructure to manage your replication. Think about it like this. Simple storage service or Amazon Aurora, right? In Amazon Aurora, when you launch a database, you get one machine, but the storage behind the machine is replicated 6 ways by design. You're paying for one machine. The storage behind it is replicated 6 ways, not 2 ways, 3 ways, 4 ways, 6 ways by design. In simple storage service, the standard storage is replicated 6 ways by design, so that you have an available possibility of storing the data with 11 lines of durability across the entire infrastructure, right? That's very natural in the cloud for you. If you have to do this in the data center, you actually have to buy all of these infrastructure and constructs, which here is very natural. Think about it. If you store about a gigabyte of table in S3 today, IoT data, just 1 gigabyte, what is your cost? It's about 2 cents a month. Try doing that in a data center. It's actually challenging. A terabyte is $27 a month. It's very challenging. How do you keep a terabyte across 6 replicas? You got to first have 6 cages somewhere, 6 storage points somewhere. You have to replicate it 6 ways. You got to buy the networks, you have to buy the pipes, and you have to set up all the infrastructure to do it. Today, what you do, you open a bucket and copy the file there. You need an army to maintain 1 terabyte across 6 locations. Today, you will copy it once and say, you know what, it's there. You don't even mentally digest it, right? But that's typically what happens behind the scenes, right? That's there. So given that the infrastructure in the cloud gives you the capability, so think about it. So cloud gives you the ability to take that architecture, deploy it in this model on the infrastructure. On top of that, you go ahead and look at the switching fabric that's available. Now today you have users who can come across the world, hit across each of the infrastructures, millions of users you can scale to, who can access these endpoints when you do that. But let's say something fails, right? Something goes for a toss. You have the ability to immediately route the user to another endpoint. Generally, a lot of people, when you look at disaster recovery, the reason we set up another center in disaster recovery is because when you have a failure, and these failures can be all kinds of, you could have a power strip failure, you could have a generator failure, you could have a rack failure, somebody could trip over a wire. Your application by itself could just fall off because of some other minor issues in the hardware of that one particular box it is sitting on. That's not a disaster. None of that is a disaster. All of these are problems in an infrastructure. A node or a blade or a box failing somewhere is not a disaster. A rack falling off is not a disaster, right? A power strip failing is not a disaster. That's not a flood, that's not an earthquake, right? So what you have had is actually a minor incident inside your data center. That incident, the only way for you to solve that in a data center world is to say, I'm going to move to my DR, because that's the only place where you can go to. Correct? That's not the situation on the cloud. Let's say your box fails, a VM fails, or a microservice fails. What do you think happens? 3 minutes later, another one launches, right? A power strip failure occurs. In about 1.5 minutes, you have another one launching. You will never have such a problem with storage anyway, because it's 6-way replicated. You wouldn't know it happened or not. So DR is when there is an entire geographical challenge that occurs to you, something massive, right? Even at that condition, you have the ability to point the user. Let's say, for example, a massive switching fabric failure occurs, that you can't reach a region. Then you have the ability to route the users to the alternate locations, the way it shows up on the slide. But then, when the recovery occurs, how do you restore it back and get the users back to the place that you want them to come back to? These are almost transparent for you on the cloud. Today, based on Route 53, based on your DNS mapping, etc., it is possible for you to have this happen practically transparently for you. You would not know which, all that you decide is which region and which zone, which region your Lambda functions you want to fire, whether within a VPC or not within a VPC. When you launch a VM, you say, I want this to launch in this availability zone, and if it fails in the availability zone, you just point it to another availability zone. You do that in minutes. That's the advantage the cloud brings to you. The traffic routing and all of that. But this creates another challenge, is that how do I ensure that the data is available at every single location that I need to do? You will look at that in some of the other sessions today on databases, and you look at that in some of the sessions that we're doing around DynamoDB, etc. Is that now Aurora gives you multi-master read-write capabilities globally, right? DynamoDB gives you global tables, and you have the ability to read and write tables globally continuously. Next comes, in talking about disaster recovery. when we say we do have a disaster recovery backup data center, what is the best description of it in your organization? The first thing is what I call, most people have what's called availability theater. You know what is availability theater? It basically says we feel comfortable we have one. Have you ever done a drill on it? I'm not talking of a DR drill that is staged. I'm talking of somebody walking in without telling anyone and pulling the plug on your existing DC and saying, I pull the plug, let me see what wakes up. How confident, how many people in this hall would be very confident that my DR will actually wake up automatically or near automatically within a matter of hours? No hands? Really? If I just go and pull the plug on one. We should have it, right? Otherwise I call it availability theater. Why is it availability theater? Because you just believe it is working. You have not tested it. A good practice, for example, if you're running a data center, is that not only do you run 15 days here and you run 15 days here. And you run 15 days here and you run 15 days here. And you keep cutting over back and forth. That is when you know you're really got a DR. Because if you're not doing those drills, you don't have DR. It's not a drill for 4 hours. It's a drill for 15 days, either side. That's true DR. The second is infrequent partial testing. A lot of people do these. We're going to do a DR drill. They schedule it 2 times a year. Go switch off all these systems carefully. Make sure that my database is really, really down. Right? Have you made sure all the blocks have been transferred? Switch off and then go say, hey man, has the blocks have been copied? Yes, good. Now it's copied. Now let's start it and see if it comes up. That's not DR. That's stage managed theater. Again, right? The key is you got to do these frequent failover tests and this. But in chaos architecture, we don't approach the problem that way. We actually have those teams that will drive that, right? When we come to teams, we'll talk about that. So switching fabric enables the capability for you to drive that kind of switching dynamically using Route 53 and the capabilities around how you want to go ahead and route the request to the appropriate areas. The third one is application failures. In application, this is not at the infrastructure plane. We got the infrastructure part, we got the switching part done. Now we look at the application part. Your application can have error returns, it can have a slow response, it can have a network partition problem with specific to that where it is not able to reach, one service is not able to reach another service. And how do you go about solving that? When you design in a microservices mental model, your blast radius is substantially constrained. Because if one microservice fails, it doesn't blast off everything else. The entire RAM doesn't dump along with it, the whole application doesn't crash with it. Only that microservices fails. And if you built your service correctly, and if you have designed, for one of the classic thing as an engineer, you have to ask the product manager is, I use service A, what should I do if service A is unavailable? Right? I'm not able to reach the service. What should I do? What should I show? I'm going to give you an example in Netflix. What Netflix does is something simple, right? They actually show you recommendations. But let's say the recommendation microservice is not able to respond back in time. But your page has to still load. They do something very simple. They pick up the last set of recommendations they showed you and they actually display it. They don't show it failed. They just show you the last set of recommendations because that's available in the log. They just read it and show it to you. Smooth recovery. It looks to you like you got recommendations, but you did not, you got something else. Right? Remember, if you step back and think about it, a lot of flows in your organization, especially in customer engaged flows, it is possible for you to make that happen. Right? You can have smooth recovery on services progressively. If your shopping cart did not update, you can update in another 5 seconds. Right? You don't have to instantaneously show it sometimes. Right? The pricing can update later. Right? Eventually you can bring the user to the right space. These are services that are possible, right? So do idempotent things to others, avoid update and delete semantics, right? The thing is, keep sure things are independent and separate as you go on. Okay, something came up, all right. Finally, the last part, which is the people layer, the mental model that we have to do, which is the one that I was thinking of. When things fail, the most mental model thing that we get into is let's reboot stuff, right? Or it's gone bad, right? And how do we therefore fix it? And how do we really want to get ahead with what we want to do? First thing is training. Fire drills is something that we all do every day in our business. It's important that we do it. I mean, there's an interesting case, right? Mexico City, before the earthquake hit them, they had actually done in several buildings the citywide earthquake drill was actually done in the city just hours before that, right? For whatever reason, right? The thing is, once they did it and the actual earthquake hit, people just followed the routine. Same thing happens in IT, right? When we do our drills correctly, we have the ability for us to actually fix issues. That means your mental model is, I am going to break things to ensure we know things are actually working. That's a key aspect of this. If you want to build really reliable architectures, you need to ensure your team has the right to break things. That's the reason we build 2 teams for that. The first team is called the chaos engineering team. As part of your team organization, you build up a chaos engineering team. This is a nice book on chaos engineering, a bunch of authors from Netflix, including Nora Jones, who have written that. What this team is responsible for is they use a set of tools to break things in your organization. Game days. These are days that they set up in which people are trained on how to go about breaking things. Simian Army, nice set of tools through which you can go ahead and it'll actually deliberately, Simian Army is just code. It's available on GitHub. You can go in there and it'll actually go restart your server, drop your server, disconnect a network plane, change the routing table, right? And it'll do it. And this will do it on production. By the way, Simian Army is run on production, not on test, QA, dev, etc. It is run on production and it is always running, right? You constantly break things to see how your infrastructure runs. And we do something very similar in AWS. We know our services are failing, or there is challenges in our services or access challenges to our services even before customers come and tell us. Because we are constantly monitoring and we are running testing patterns to validate that whether these services are up and running and how they are. And this is not something we do as test when we deploy. This is continuous testing. It's happening in production. Simian Army, Chaos Toolkit, CHAP, Gremlin is for underlying infrastructure, through which you can look at ways to have this team focus on how do I fail continuously and how do I ensure that the reliability on my infrastructure, my switching plane, my application layer is really, really stable. Remember, you are approaching this from a CTO. The business is not going to tell you do this, right? You are going to go ahead and build it this way. That means you are very confident that when something works, it works. And when something fails, it fails. The second team that you're going to have is the security team. Security is priority 0 across the board. The security team is going to have a set of tools. And this team is going to be responsible for driving things around your, how do I attack? They are going to do The red team is going to attack your infrastructure across all security planes constantly. This is the second part of the team. So very similar to how you have your dev team, QA team, DevOps team, etc., etc. These are 2 teams that you want that adds reliability to your engineering path. Right? As a CTO, focus on these areas, look at how you can build that and take it forward. Break it to make it better. Right? That's the attitude these 2 teams need to carry, and your developers should work in that model to drive that forward. They need to be able to think about the construct of how do I work in a construct where I know when I push it to production it's going to break worse than it broke in my dev. This gives you the ability to build these kinds of services, build the kind of outcomes that you need. That will ensure that when your business comes to you and says, hey, I want to try something, I'm confident it would run. I can make those changes for you. I say more yes than no. Right? Experienced staff, robust applications, dependable switching fabric, redundant service foundation, cloud native availability model. Thank you.